Under the topic definite integrals, here we have a very simple problem. The question is to evaluate integral 0 to pi by 2 logarithm of tan x dx. As the first step, we shall consider the given integral as capital I, which is equal to integral 0 to pi by 2 logarithm of tan x dx. Now, this integral will also be equal to, that is, first of all, we shall mark this as equation 1, and this integral will also be equal to another integral by using a property. The property says that integral 0 to a f of x dx can be written as integral 0 to a f of a minus x, that is the upper limit minus x dx. So using this property in our given integral, we can replace this value x by the upper limit minus x. Here the upper limit is pi by 2, and so we can replace it by pi by 2 minus x. So this integral I will also be equal to, so I is equal to integral 0 to pi by 2 logarithm of tan x. So instead of x, we are going to replace it by pi by 2 minus x and dx. Now if you see, under trigonometry, we know that tan of 90 minus theta lies in the first quadrant, and all the angles in the first quadrant, that is tan of all the tan x, will be positive. So therefore, and there will be a change. Now here you have tan 90 minus x, so the change will be cot x. So therefore, by using the trigonometric identity, we know that tan pi by 2 minus x is equal to cot x. So let us use this identity over here. So we get the integral I to be equal to integral 0 to pi by 2 logarithm of cot x dx. And let us mark this as equation 2. Now we can add equation 1 and equation 2. So if you see, equation 1 is, the left hand side of equation 1 is I, and the left hand side of equation 2 is also I. So adding equation 1 and 2, on the left we get 2I, because it is I plus I, is equal to the integral on the right can be taken common because both have the same limits, so 0 to pi by 2. And within the integral, you will be having logarithm of tan x, which has to be added to logarithm of the second integral has cot x, and we have dx. So now this by using a property from logarithm, we can rewrite this. That is, from logarithm we know that log a plus log b can be written as logarithm of ab. So log a plus log b can be written as logarithm of product of a and b. Here tan x can be treated as a and cot x can be treated as b. So if you do so, we will be getting logarithm of ab, where we can rewrite this as log tan x cot x dx. So let us rewrite it. So we get 2I to be equal to integral 0 to pi by 2 logarithm of tan x cot x and dx. Now again, by using the trigonometric identity, we know that cot x is the inverse of tan x. So this can be written as, so this is equal to integral 0 to pi by 2 logarithm of tan x. This cot x can be written as 1 by tan x dx. And these two can be cancelled, and we get this to be equal to integral 0 to pi by 2, and here we have a log 1 dx. But we know that log 1 is equal to 0. Therefore, the complete integral becomes 0, and so this will be equal to 0, and hence we get 2I to be equal to 0, which implies that our integral I that we have taken is equal to 0. Hence, we have got integral 0 to pi by 2 logarithm of tan x dx, this complete integral, to be equal to 0. Hence, we have evaluated this integral. So, I hope you would have understood this problem. Kindly follow the next video lecture for more problems under the topic definite integrals. Thank you.